What we do here also, we take a position array of size n and we call this approach 2. What we do, we pass array A, we pass size of array A, we pass position array, and we also pass where in original array we are, where in position array we are. So we say original array we are in AI, position array we are in PI. Ideally order doesn't matter, in whichever order we want to write we can write it. So this is AI, this is position array, this is PI. Now the difference wise, what is the difference here? We are making a decision based on AI. So we can take AI or leave AI. That is the call that we are making. Now think about it. When we are taking AI, that means in position array at PI index, we are filling A of AI. This is the take part. We have taken it. When we have taken this, in recursively, what next index you want to fill? We'll say A as it is, N as it is. Next element we want to decide on recursively. Position array remains as it is, and we say, hey, focus on filling the next index family. Because PI is already filled, you go ahead with the next. Now if we say leave option, we do not take this AI element. So what we do is we say AN AI plus 1. We still have to consider the next element, but the change will come over here. We still want to fill PI only, because we are leaving current element. That means PI position is not yet filled. So this is the leave option. I'll just remove and I'll call it, this is leave option. Right, so just see this, what we are doing. Now if you are filling, leaving, eventually in this we print at the last level. So we print in the end, if AI has become equal to N, then what we do, we eventually print our subset here. Okay, I need to bring that function that we wrote. So I just copied that to another file. Let me bring this function back where we were printing the subset. So previous functions I have moved to another file, so just brought it back. So now we want to print the subset, and here when we want to print the subset, ideally we will pass position array and we will pass PI directly, because here PI is telling us what position to fill. It's not the currently filled position. And rather than break, I'll write return. So if you see here, we end up printing all the things. So just see, it's a binary tree approach. We are making only two recursive calls. Previously, we were making multiple recursive calls by writing them in a loop. So this is our approach 2. We are calling that approach 2. Let's try to compile and run this program. Oh, just a minute, some error came. Yeah, here I have missed a semicolon. Yeah, so that's the compilation error I was getting. Yeah, let's compile and run. So now if we see, it is first generating 1, 2, 3, because left, you are taking take element, take element to take element, it becomes 1, 2, 3. Here we say after this leave 3. So if we are leaving 3, we will get 1, 2. Here we took 2. This was take 2. This is leave 2. If we leave 2, what we end up with here is, here we end up with 1 only, and then we decide here take 3 and leave 3. When we take 3, it becomes 1, 3. When we leave 3, it becomes 1 only. So if you see the order 1, 2, 3, 1, 2, 1, 3, 1. Now at top position here it was leave 1. This was take 1. So when we leave 1, we are still left with 3 position. Here we take 2, leave 2. So it becomes 2 dash dash. Leave 2 is again dash dash dash. Here we say take 3, leave 3. So when we take 3, 2 becomes, it becomes 2, 3, and when we leave 3, it becomes only 2. Here when we take 3, it becomes 3. When we leave 3, it becomes empty. So ideally, if you see in the end, one empty array is also printed. So these are our subsets. So if we just want to discard empty set, I can also do that. I can say if PI is not equal to 0, only then go and print the subset. So this is the way to discard printing empty subset. So ideally, if we do that, after 3, extra new line will not come. So yeah, you see this. After 3, there is only 1 new line. Previously, there were two new lines. So that is kind of discarding the empty set. Well, so this marks our approach 2.